welcome to True Projects. In this video, we will explain about self-organizing networks for 3GPP LTE. Introduction. Self-organizing networks, which are SON, is a wireless industry automation technology that simplifies network planning, deployment, operation, optimization, and healing. Legacy SON functions are primarily concerned with network automation and optimization via globally applied rules and policies, with no regard for application characteristics or user quality of experience. The development of enhanced mobile wireless networks, on the other hand, has underlined the necessity for network automation to attain peak performance. To verify the effectiveness of self-optimization algorithm in realistic 3GPP LTE network settings, experimental systems have been constructed. The relevance of SON in optimizing handover procedures and enhancing overall radio network performance cannot be overstated. SON technology offers the ability to reduce human intervention and increase capacity in context of LTE advanced heterogeneous networks by self-configuring and self-optimizing techniques. Objective. The project intends to implement self-organizing networks in 3GPP LTE networks in order to automate network operations and achieve optimum performance, as human configuration is costly, time-consuming, and prone to errors. The project's goal is to assess the efficiency of the random forest machine learning classifier in the context of 3GPP LTE network data analysis. SON approaches ensure operational efficiency and simpler network administration for mobile wireless network, resulting in a greater end-user quality of experience. These are the requirements needed for execution. Coming to hardware requirements, operating system of Windows, processor of 5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDE of 3.7 version is required. These are the design modules in the project. First one is upload 3GPP LTE dataset. Using this module, it involves loading the 3GPP LTE dataset obtaining from GitHub repository into the project environment. The dataset contains various attributes related to 3GPP LTE network. Next one is preprocessed dataset. In this module, the located dataset is preprocessed to make it suitable for machine learning algorithms. This involves handling missing values and converting non-numeric data into numeric values, enabling the dataset to be utilized effectively by random forest. Next module is split dataset into train and test. The dataset is divided into two subsets, which is training set and testing set. Typically, it is larger portion of 80% is used for training and the random forest classifier to learn patterns from the data, while remaining portion, which is 20%, is reserved for evaluating the classifier performance. Fourth module is run random forest algorithm. The random forest algorithm is chosen for its accuracy and ability to handle complex network data in predicting 3GPP LTE network attributes. Its ensemble approach mitigates overfitting and noise, making it robust choice for optimizing network operations and enhancing performance. This is the heart of the methodology. This module involves training and evaluating of the random forest machine learning classifier using prepared datasets. The classifier learns from the training data and then tested on the separate test data to predict network attributes and assess its predictive capabilities. Fifth one is random forest performance graph. After running the random forest algorithm, this module generates a graphical representation that visually summarizes performance metrics achieved by the classifier. For execution of the project, first open the code folder. This is the code folder of the project, and this is the dataset file. And this is the 3GPP LTE dataset. Here are the attributes of the project. And this is the main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we will be interacting with the program, and this is created by using Tkinter library. So first click on the button Upload 3GPP LTE dataset to upload the data. Select the 3GPP data and click on Open. Here it is confirmed that dataset is loaded, and here we can view few records of the data. And here in the data we have 8479 rows and 26 columns. Here in data we have non-numeric values, which means they are string. Machine learning algorithms cannot accept non-numeric data, so they need to be converted into numeric. For that, we need to pre-process the data. So click on the button Pre-process dataset. Here, dataset is pre-processed. Now click on the button Split dataset into train and test to split the data. Here, total records in the data are 8,479. After splitting them into train and test, in train we have 6,783, in test we have 1,696. So, when we build the algorithm, first algorithm will train model on 6,783 records and then evaluate on 1,696 records. So now, click on the button Run Random Forest Algorithm. Here, we have accuracy, precision, recall and F-score of random forest algorithm. Now click on the button Random Forest Performance Graph to see all these metrics in graphical format. Here on x-axis we have the metrics and on y-axis we have the scores of that metric. So this is the accuracy, this is precision, this is recall and this is F-score. By this we can understand that model is performing well. Exit this GUI. Conclusion. The project highlights the enormous potential inherent in self-organizing networks for stimulating the evolution of 3GPP LTE networks, while traditional SON functions lay the groundwork of network automation. Its inherent limitations in accounting for applications, complexities, and user quality of the experience have come to light. With the emergence of sophisticated mobile wireless networks necessitating an upgrading paradigm of automated orchestration to achieve optimal performance, this project takes determined strides to bridge this divide. The verifiable effectiveness of self-optimization algorithm is vividly depicted through rigorous real-world trials within the scope of actual 3GPP LTE network scenarios. By combining powerful machine learning algorithm paradigms such as random forest classifier, the project expands on the potential of not just improving the network operations but also dramatically improving end users' experience.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.